Okay, so we're into this realm of probability distributions and um, what happens when you make changes to the elements within those distributions. So let's talk about um, the key measures that are used in a probability distribution. Usually, the two big ones are what we call the expected value, or another way of saying that is it's the mean of the distribution, and the other one is its standard deviation. Okay, this is a measure of center. This is a measure of variation. Okay, so when you start combining or changing distributions, things that are measures of center, also measures of location, tend to do the same thing. And things that are measures of variation tend to all do the same thing. Um, the measure of center would include things like the mean, the median, um, the location of the quartiles. That would be the mean and the median would be measures of center. The measures of location would be including things like the quartiles, the percentiles, etc. Would fall under this category. Things that are variation would include things like the range of the data, its IQR, the standard deviation, are all affected in this. Okay, so these are the two big categories where things can be affected. So we're going to look at two conditions. One, where we take each and every. So remember, a probability distribution has like a set of values for x, and then the probability that those values happen, right? So the values for x and the probability for those to happen. Okay. So the first thing we're going to do is we're going to say, well, what if I take all these values and I add a number to them or I multiply a number to them? Right? So that's going to be the first thing. And then we're going to look at what happens to these and what happens to these. Okay. The second thing we're going to do is we're actually going to create a second distribution where we have a value for y and a probability distribution for y. And what's going to happen? What do I get as a result of this if I add this value to this value? Right? Or what do I happens if I subtract them? Right? So those are going to be the two circumstances. One is just look at what happens if I add a value to each of these, what happens if I multiply each of these by a value, and then what happens if I combine these in some way by either adding or subtracting. Now, when we do the adding or subtracting between these, we're going to assume that these two events are independent. Because if they're not, then if there's a conditional probability here, this is a much more complicated problem that we're not going to kind of get into today. Okay? So, all right, so let's start there. Let's deal with one distribution. What happens if I add or multiply? Okay, so I have one distribution, right? So I have these x values, and I have these probability of x. And this could be either a continuous or a discrete distribution. It doesn't matter. So it could be something here, or you could have like the probability of x is some, the probability distribution of x is some function of x, right? Where the integral, the probability of x being between a and b is the integral from a to b of that function, right, dx. So this is like the continuous case, but you're never actually going to do an integral in this class because the functions that we give you are going to either like be uniform or normal, where you can either work a rectangle or you can work something that's like a normal curve, which is all built into the calculator, right? So what happens? So if I take all the x values and I add a constant, then what happens to the measures of center and location? And usually the one that we're most concerned about here is the expected value, or the mean of that, right? It could be the median, it could be the quartiles, the percentiles, etc. So if I add the constant, then this becomes the expected value plus that constant. And if I do this with measures of variation, there is no change. Okay, so no change, C-H-A-N-G-E, no change. So the measures of variation are not going to change. Everything's just going to shift left. Now, if it's a subtraction, it becomes minus the constant. Still, variation is no change. Okay, so not so bad there. So this is what happens if I add or subtract a constant from each of these values. It's just going to shift the whole pile either left or right by that value, which means the center will change. It'll either shift left or right by that value, but the variation will not change. Okay, so that's an important reality. So let's look at what happens if I multiply here. Okay, so in the multiplication case, I still have these values. I have the probability of these values, right? But now we're going to say what happens if I multiply this value by some constant, right? So let's say I'm going to multiply it by, I don't know, we'll call it the constant b, right? So we're going to take b times each of the x's, right? So if I multiply by b, then the center also multiplies by b. So the measures of center and location will also multiply by b. So like your new expected value, right? B will be b times e of x, or b times the mean of x, right? And for variation, this also multiplies, okay? So this is the fun part. So both the center and the variation. So variations, things like standard deviation, IQR, range, they're all going to multiply as well. So the new standard deviation will be b times the standard deviation of the original distribution. So if I multiply them all by b, I change both the center and the measure of variation. Okay, so now we're going to combine two distributions. So we'll have an x distribution, right, with probabilities of x. We have a y distribution of probabilities of y. And now we want to know what is, if I add the x and the y, what's the probability of getting that result? Okay, so what we need to concentrate on is what happens to the measures of center and the measures of variation. All right, center and location. Okay, so these are, so the only ones that matter here are going to be the expected value and the standard deviation. So let's talk about expected value here. The expected value of x plus y is really just the expected value of x plus the expected value of y. So that's pretty simple. Or the mean of x plus y, same thing. It's the same as the mean of x plus the mean of y. Okay, variation, you have to go back to the variance. Okay, so standard deviation of x plus y is not going to help me here. So I have to go to the variance, which is the standard deviation squared. And then I get standard deviation, or variance of x plus the variance of y, which means that the standard deviation of x plus y is going to be the square root of the two variances. Okay, so when we add a second pool in this, we should expect variation to be increasing. Remember, these have to be independent, because if they're not, then we have a problem. Okay, so this works out. Now, here's the fun part. If I make this minus, this becomes plus or minus. So the expected value is just going to work for subtraction. If I make this minus, we still want the variation to increase because I now have two things in the pool. This stays plus. So whether we're adding or subtracting the two probability distributions, it always stays plus in the formula. All right, so there you have it. This is combining probability distributions. And if you, well, adjusting and then combining. So if you're um, adding or multiplying a number by a single distribution, adding is going to change only the measures of center and location. Multiplying will change everything. When you are combining two distributions, the measures of center follow the combination. So if it's adding, the measures of center become adding. If the subtracting, the measures of center become subtracting. When you're playing for the standard deviation, whether you're adding or subtracting, you have to break back to the variance and then take the square root of the sum of the variances either way. So whether it's plus or minus, you're going to do sum of the variances and then take the square root. All right, there we go.